We've got a map scale 1 centimetre to 25 meters. So if you have some number of centimeters, you would times by 25 to get the number of meters. And then to go from meters back to centimeters, you would actually divide by 25. So here it's going to be 240 over 25, which gives 9.6 centimeters. Then we can write it as a ratio, 1 centimeter to 25 meters. But this is okay, but they've got different units at the moment, and for this ratio, it's implied that they'll have the same unit. So we need to change meters into centimeters. That makes the most sense. So we'll times through by 100, and then we'll get 1 centimeter to 2,500 centimeters. Now it's the same unit, and we don't need to actually write the unit in there. That's implied. So K is going to be 2,500. For this next part, if you're using a handout that I've made, you should get that the length BC is 12.6 centimeters. If you have the original GCSE paper and it's been printed to full size, it should also be that. You can kind of get away with it though, like as long as it's roughly that. You might get a slightly different answer if yours is not that amount. Okay, but still the method will be the same. So we've got a new play area, and it must be no more than 150 meters from B. Okay, so I'm going to need my ruler still. Right, 150 meters. Now we've got that 1 centimeter represents 25 meters, so it's going to be 150 over 25 to get the number of centimeters needed, and that's going to be 6. So no more than 6 centimeters from B if we're using our scale. We'll need a compass for this. And we'll set it up so that it is 6 centimeters, which you can just about get away with. It's pretty good. Right, so no more than 150 meters from B. So I can draw this arc around like that. That is precisely 150 meters from B, so it's got to be less than that. The points are going to be inside here. But it also has to be closer to AD than to CD. AD and CD, that's here. And what we're going to need to draw is an angular bisector. The angle bisector splits the angle perfectly into two, and it gives you the line that's the same distance away from the other two lines. That's a consequence that you get. So drawing an angle bisector, bring the compass back round. Okay, first things first, put the point on D and just draw a small little arc. It doesn't matter exactly what the radius is, but don't make it massive, don't make it tiny, just, something a bit like this. And then, so those are all the points at the same distance away from D. What we then do is we put the point on this position here where it touches the line, and we draw an arc inside like so. We keep the compass the same. You don't actually have to do that, but we will here. And then we put the point on the other one, and we draw another arc. Now what this means is essentially we've created a rhombus, because this length to here and to here and to here and to here, they're all the same, and it so happens that when you draw we're basically drawing a diagonal through a rhombus, and it will split the rhombus into two, and the consequence is that it will split this the angle into two. So I'm going to do it all the way like so, and that is the line that basically splits the angle into two, and it also will mean it's the same distance away. This line is the same distance away from CD as AD. So where is it closer to AD? Well, it's going to be everything to the left of the line. And the important bit is over here, where we already have a bit of a region. So the play area, obviously it must be within the park, and then it's got to be within 150 meters from B. It's got to be closer to AD than to CD, so it's going to be this. I've shown all my construction lines. It's going to be this shaded area here.